So far, the core logic of shooting in the game has been basically completed. Now let's build the game scene to give players a better visual experience. As for art resources, you can design them yourself or get them through search engines. We also provide you with some art resources in our editor. Click the window menu, click Panel, and then click Asset Store. The Asset Store dialog box will pop up. There are categories on the left, and you can choose the assets you need according to the actual situation. First, right-click in the hierarchy window on the left, and create a new empty node. Name it Environment. Used to set the environment around the basketball court. In the Asset Store dialog box, select Building. Find a suitable building. Click Download. After downloading, you can drag it to the environment node in the hierarchy window on the left. Then restore its position to 0 so that the building is in the center of the scene. Then adjust its position and size. According to the shape of the added building, add a suitable collision body to the building. Repeat the above operations to arrange some buildings, trees, roads, etc. around the basketball court. Due to time constraints, I will not give you a live demonstration here. I will just use the environment prefab that I have prepared before. Adjust the ambient light as needed. To prevent direct sunlight from affecting the player experience when shooting, we can rotate the light direction 90 degrees around the y-axis. Make the sunlight to the left and right of the player, not the front and back. Change the ground color. Select all buildings. Set the level to building. At the same time, in the hierarchy script, add a level. In order to make the basketball emit sound effects when it collides with the building, we need to do some processing. First, in the hierarchy window, find the Audio Manager node. Create a new empty child node under its child node SFX. Drag the appropriate sound effect to the inspector window on the right side of the newly created empty child node. Remove the Play on Awake attribute. Change the node name to be consistent with the sound effect name. Then, open the basketball control script. Find the sound effect processing method in it. Add relevant processing so that the basketball emits reasonable sound effects when it hits the building. Save. Run and test. The basketball is thrown towards the building, and the sound effect is normal. We still need to consider one thing. That is, if the basketball is thrown too far and falls into the void, it will cause the game to stop. We have limited the force and expanded the ground. If the ground is large enough, no matter how you shoot, it will not fall into the void. Here, just in case, we can limit the basketball to move only within the basketball court. In the hierarchy window, create a new empty node. Switch to 2D perspective and observe in the top view. Drag the node to the four corners of the basketball court. You can test the range of basketball movement. Record the range of basketball movement in the X and Z directions. Then, in the basketball control script, find the movement processing logic. Add a method to determine whether the basketball is out of bounds. And make a judgment in the basketball movement processing method. If the target position to which the basketball is to be moved is outside the basketball court, it will not move. Save. Run and test. The test passed, and the basketball can only move within the basketball court. In order to make it easier for players to determine whether they are aiming at the basket, we designed one of the seams of the basketball to always face the basket. And when the camera rotates, this seam is always facing forward. That is to say, the basketball should rotate with the camera. And before each shot, the direction of the basketball should be restored to the rotation angle of the camera. Find the camera control script in the left and right rotation processing branch of the onLatUpdate method. Add the logic to control the rotation of the basketball. Open the basketball control script. Find the preparation operation before shooting. Add the logic to modify the rotation of the basketball. The rotation angle of the basketball is consistent with the left and right rotation angle of the camera. Save. Run and test. It is found that no matter how it rotates, the basketball will always have a seam facing forward. And no matter how the basketball rotates during flight, it can ensure that before each shot, the basketball will always have a seam facing forward. Hide the environment node and make sure that all environment-related elements are placed under this node. Then, show this node and drag it to the prefabs folder to make a prefab. In the same way, we can make prefabs for multiple environments to facilitate the subsequent scene switching. Due to time constraints, I will directly use the environment prefab designed during class preparation. Save. Run. During the running process, it was found that the basketball may fall into a building. Then it does not return to the initial state, causing the game to be unable to continue. Open the basketball control script and find the relevant methods for collision processing. In the flight processing logic, add judgment conditions. If the level of the object colliding with the basketball is a building, relevant processing must also be performed. Similarly, the corresponding processing is also performed in the onCollisions method. Save. Run. During the running process, we found that the basketball occasionally fell on a building and could not be retrieved. The reason is that we forgot to set the level for all buildings. To solve this problem, select all buildings and set their level to building. However, there is a small problem with this. In case there are other objects that forget to add levels later, or some levels are added, such as the basketball falling on a plant, do you have to modify the code again? What to do? To solve this problem, we can do this. When the speed of the basketball is 0, touching the basketball will change the state of the basketball to idle. But since the basketball is a 3D object, we need to use ray detection. In order to take into account the feelings of students with zero foundation. Before using ray detection, we will briefly introduce the principle of ray detection. We have an animation demonstration here, please take a look. First, launch a ray from a certain point. Usually choose to launch a ray from the main camera. If the ray and the collision body collide within the detection distance, the corresponding information will be returned. Our goal is to realize that when the basketball is touched on the screen, the basketball will be picked up. Open the Menu controller script. In its own update method, determine whether it is multi-finger touch or mouse click. If it is multi-finger touch, get the coordinates of the first touch point. Then call the method to pick up the basketball. If it is a left click of the mouse, get the mouse click position. Then call the method to pick up the basketball. In the method to pick up the basketball, use ray detection. First, launch a ray from the main camera to the touch point. Then, use ray detection to set the detection distance and detection level. If the information returned by the ray detection is not empty, and the collision body that collides with the ray is not empty, then change the basketball state to idle state. Because we only want to perform collision detection on the basketball level here. Don't forget to add a basketball level. Set the level of the basketball node to basketball. Here, it is necessary to explain the relevant parameters in ray detection. First, if I touch this big ball, a ray should be emitted from the camera lens to the touch point on the screen. The touch point is a two-dimensional vector, which is a point in the camera's picture. So when passing a three-dimensional vector, its z-coordinate is set to 0. In the ray detection method, the second parameter refers to the maximum distance of the ray detection. The third parameter refers to the level of the ray detection. The third parameter needs to be emphasized to everyone. Why use one to shift the level bit left here? Because bit operations are used here. The binary corresponding to the decimal number 1 is 0, 1, and shifting 8 bits to the left becomes 0, 1, 0, 0, 0, 0, 0, 0, 0. Counting from right to left in binary, the 8th bit is 1, which means the layer with detection level 8, that is, the layer where the basketball is located. If all layers need to be detected, just write -1. Because all bits of -1 in binary are 1, that is, 1,111,111. If you want to detect the first and second layers, write the decimal number 3 corresponding to binary 011. If you want to detect the first and third layers, write the decimal number 5 corresponding to binary 0101. Save. Run and test. The basketball is thrown onto the building, and we can pick it up. Even during the flight of the basketball, we can block and steal. At this point, the game scene has been built. The various functions of shooting are basically complete. You can build a few more scenes after class to switch scenes.